Hello everyone and welcome back. Today we are discussing whether a concrete beam will crack under its own weight or not. While the concept may seem simple, understanding the underlying logic is essential. Concrete cracking is a crucial issue that can significantly impact the ultimate load capacity of beams. Let's start by reading the problem. The problem asks us to calculate the maximum moment of the rectangular concrete beam when subjected to its own weight. The beam's cross-section is 350 by 500 mm and the span is 6 meters. The concrete is on normal density of 2500 kilograms. If the compressive capacity of the concrete is 30 megapascal, do you expect the beam to be cracked under its own weight? We have a hint here. You can ignore the weight of the reinforcement. The beam's own weight is represented by a uniformly distributed load. Now, how can we solve these kind of questions? Let's take a look at the solution approach. Number 1, we find the self-weight per unit length. Number 2, we find the maximum applied moment. Number 3, we find the stress based on the applied moment. And finally, we find the modulus of rupture and compare it with the stress. Before we start solving, what's the definition of the modulus of rupture? So the modulus of rupture of concrete is a measure of its tensile strength in the tension zone of the concrete material. In other words, it's the tensile capacity of concrete. Once the concrete reaches this point, the concrete will start cracking due to the tension stress. Now let's move on to the solution. We have given the cross-section area, the span, concrete density, and the compressive strength of concrete. The first step will be to calculate the unit weight of concrete, and this can be done by multiplying the density of concrete by the gravity. Then we find W, which is the beam self-weight, equals to gamma concrete multiplied by the volume of the cross-section. Then we calculate the maximum moment, and based on our condition here, the maximum moment can be calculated by multiplying the uniformly distributed load by the span square over 8. Then we calculate the stress, and it equals the maximum moment multiplied by y over the moment of inertia. After that, we calculate the modulus of rupture, where lambda is equal 1 for normal density concrete, and y is the distance from bottom edge to the neutral axis, because this is where the tension is happening. Note that if the tension is happening on the top of the beam, you have to take the distance from the top to the neutral axis. And the moment of inertia is equal to bh cubed over 12. Finally, if the modulus of rupture is greater than the stress, then the section will not crack. Okay, now let's move to the numerical solution. We start by finding the unit weight of concrete. Next, we find the distributed load due to the own weight of the beam. Then, we find the maximum moment. Then we find the moment of inertia of the section. After that, we find the stress. And finally, we find the modulus of rupture. And here we can see that the modulus of rupture is greater than the stress, which means the section will not crack. Thank you for watching and see you in next videos.